Hi everyone, thank you very much for tuning onto this channel. Today's topic is based on how to draw up shear force diagram of a simply supported beam. And before we start with our work for today, please don't forget to subscribe or click on the red button. And again, please watch this video till the end because I really don't want you to miss any single word from my mouth because I regard it as valuable. Hence, I'm presenting it to you. Right. So without any waste of time, let us start with our shear force diagram. Good people, the beam that I brought forward to you is the old beam from the previous video that we have dealt with on how to calculate the reactions. For us to throw up shear force diagram, I've decided not to come up with the new beam, but instead I decided to bring the old beam that you know, but now performing different calculation on it, right? So now let me just write the magnitude of R that we calculated. It was 83.654 newtons, and that of L was 66.346 newtons, 3.46 newtons, and I will also have to add here S and T, labeling these lines, right? Now, for us to confirm that these forces are correct, let us just confirm by applying Newton's third law that states that upward forces equals downward forces, right? For upward force, we have 6.36 plus 83.654 equals to 65 plus 85. So when you add the two, when you add both sides, you must get 150 both sides. 150 both sides. So in this case, we are good to go. We are sure that our beams, our forces are balanced. That means this beam is now equilibrium, while the forces are balanced, right? Now, I must also explain what it means by shearing. So let me just have it in a form of boxes here. Let me just draw this box. Let me just draw this box, and this other one next to it, and then apply force here. Then apply force, and then apply force over there, right? So and after force is being applied, I'll just draw a second scenario now. Second scenario, and then of that box. So after we have applied force on this is a real situation that takes place. That means this box, okay, let me name this A and B, A and B. You can see that after force is being applied on B and on A moves up and B moves down by shearing. They are pushing against one another. So that is basically the impact of force. That is basically the impact of these forces on a beam. This is really what is happening in reality, right? So our shear force diagram is simply the graphical presentation of this impact of forces on a beam. So before you study the shear force diagram, because now drawing involves scale. If you are being detailed, remember engineering. This is engineering. So I can say 1 centimeter. 1 centimeter equals 50 newtons, right? So having said that, I can now start with my shear force diagram. But before I start with my shear force diagram, I normally like to prepare my planes, my Cartesian planes that I'm going to use, and obviously use my ruler. So here is my ruler that I'll use to draw up my shear force diagram. So remember, this is just construction lines. I'm starting first with the construction lines, hence I'm using gray pen, right? Having drawn that, Let me just draw my other lines here. You see the importance of these gray lines. We haven't started with our shear force diagram, but we are preparing our axis now. We are preparing our lines. So let me just draw this line here, starting from there till there. These are just construction lines. Remember, right? And then you have this line, good. And then we have this one. People, this is basically what you must do at home or wherever you are when solving these problems, right? So this is the last line. This is the last line that must show on your scale, right? So this one I'll explain after why am I showing it. One might not find it very necessary, but you'll see the importance of it. Let me just hide it also. Right. So now that I've written that, let me just start with my shear force diagram. So I will prefer to use the different color. Right. Now remember, shear force diagram starts from 0 and end at 0. Right. So it starts here. It's going to start here at 0 and end at 0. And with our scale, I'll just do this 0 there, and then I write 50, 50, and then I write 100. Below here, I will just say 50, and then minus 100. Right. Remember, we're doing shear force. We're showing shear force diagram, and all the forces that you see here, they will be in newtons. Right. So we are good to start with our shear force diagram at this point in time. So I'm just going to put my ruler in a horizontal position as my starting line, right? So I'm just going to draw this first line. Why do I draw this first line? Is because I said my shear force diagram must start at 0 and end at 0. We shall see about that. We shall see about that. So our first force that you're going to start with will be 66.346. Remember, I usually start from left to the right, but it doesn't matter if you can start from the right to left, but it's always proper to start from left to right. Okay, I hope you're still with me. So our first force is 66 and it's pointing upward. So all you have to do now is just to press your calculator, 66.346, and then of course draw this line here till 66. Right, there you are with your 66. And please don't hesitate to write this magnitude. So you have 66.346 newtons, right? So between L and S, there isn't any force. There isn't any force that has got an impact or exerting load on our beam. So we're just going to draw the straight line. We're just going to have our straight line from this point to that point. So we have that till that point. So when you get to S, there is a point load of 65. Remember, downward forces are regarded negative, upward forces positive. Right. So we are going to say on your calculator 66.346 minus 65 minus 65 minus 65. That must give you 1.346. Right. So let us quickly draw that line. Let us quickly draw that line from that point. So you have, that's it. That's it. That looks beautiful. Now let us just jot that point down before we forget. So we have 1.346 newtons. That is that point. So between S and T, there isn't any force. There isn't any force. There isn't any force that we can. There isn't any force at all. So right, let us carry on. We are almost there, good people. There isn't any force. So let us just have this before we lose power here. We draw this line up until 85. Right. So when you get to this point, there is a point load again of 85. So you simply say 85 minus 1.346 minus 4. That, so your answer will be 83.654. Let us just do exactly that. Let us just do exactly that. 89, let us see, 90. Right. So let us draw this line quickly without any waste of time. Right. So there is our line. There is our line. So we can say that point is 83.654 newtons. 54 newtons or 4 newtons with people. You might just have it like that. And then between T and R, there isn't any force. There isn't any force with people. Let us see this right. So we just draw the straight line from that point till the end. Till the end, right? So at that point with people, you have 83.654. That is negative. That is negative. So at the end, so let me just write this negative so that you don't forget this is negative. So plus that, it must give you 0. 83 plus that gives you 0. Let me just simplify this so that our diagram can be perfect. So we have this. That is our diagram. Our diagram must start at 0 and end at 0. Let me just remove this ruler now. So below here is negative. We have plus and plus there. So good people, there it is with our shear force diagram. I hope by now you are comfortable on how to draw up shear force diagram. Please don't forget to subscribe to have full access of my videos. Thank you very much for watching. Hope to see you on my next video. Cheers.